Understanding the tangent ratio. Question 1. What can be possible values of tangent ratio in an acute right triangle? Well, this is a very good and interesting question, and it gives us range of tangent ratio, right? So what I will do is I'll start with a 45 degrees triangle, right? So let me draw 45 degrees triangle for you, approximately, right? So this is a triangle which I'm assuming is a 45 degrees triangle. Well, 45 degrees right triangle will really mean that the other angle is also 45 degrees, correct? In that case, these two sides will be equal. So it's an isosceles right triangle, correct? Now here, you will see since these two sides are equal, so we know one thing, that is tan of 45 is equals to, let us say this side is A, then this side is B, right? Then we say, well, A over B is equals to 1 here, since A is equals to B, right? So in this case, A is equals to B. So tan 45 degrees is 1. So that is what we know, right? In a right triangle where angles are 45, it's an isosceles triangle. The two legs are of same length, and therefore the ratio will be 1. So that gives us a starting point to understand what tangent ratios could be in a right triangle. Now let's consider a triangle which is less than 45 degrees. Let's say like this, correct? Now what happens to A? The value of A decreases, correct? So as the angle A decreases, so we have as A is less than B, then what happens? The angle decreases, right? So angle decreases. As it decreases, the value becomes lesser than 1, right? So we have tan, let's call that angle to be theta. So we have tan of theta, which will be less than 1, correct? But how less can we go? That is what is to be seen. What is the limit? What is the limit? How less can we go? So let's go further less, further less. So it is maybe very small. It can be exactly like this, where A could be 0, right? So we can write that A approaches 0, that means kind of 0 degrees. That means theta equals to 0 degrees. In that case, tan theta is equals to 0. Do you see that? So tan theta can go from 1 to 0 as we decrease the angle. Now let's see what happens as we increase the angle. So now let's increase theta. So now we say theta is greater than 45 degrees. Then what happens? So let's look into that scenario. That means we are talking about triangles which are like steeper, like this, right? So as you can see, A value becomes very large, correct? So in such cases, we know A will be much greater than B, right? So tan theta, which is the ratio of A over B, will be greater than 1, right? So what could be the maximum limit? That is what we need to know, right? Maximum could be that this line can be vertical. Do you see that? It can go right there and it could be like this. Well, I know that will not be a triangle, but it could be approaching this. So what I'm trying to say is that theta is approaching 90 degrees. So in that case, what happens? In that case, as A increases, B shrinks. B becomes lesser and lesser. But as you approach 90 degrees, B approaches 0, right? B approaches 0 and A becomes very large. So what is A over B? And we know tan theta is equals to A over B. As B approaches 0, tan theta approaches infinity. Do you see? Infinitely large. Do you see? Therefore, what we can say that the range for tan theta is all real numbers. Is all real numbers. Do you see that? All real numbers. So it could be from 0 to infinity. Of course, infinity is undefined. We say when theta is 90 degrees, tan theta is undefined because infinity is undefined. Okay? So, but what you can see here is that the range of tan is actually all real numbers. It is from 0 to infinity, right? In that small right triangle, it gives you all possible values from 0 to infinity. So that is what tangent ratio could be. Okay, I hope you understand and appreciate it. Now we will do many examples which will help you understand the tangent ratio and its application. Thank you and all the best.